Alright, welcome to another part of the video. So here I will show you the solution of general equation. So let's refer back what we have learned the last part. So we found that the general equation for the general equation of damped oscillation. Okay, damped oscillation, which is x square, x double dot, x double dot, not x square, x double dot plus with the gamma over m, x single dot plus with the omega naught squared x. Right? So here is our general equation of damped oscillation. Okay. Now, what is our purpose? Okay. Our purpose is to find the solution for xp is equal to exponential power of alpha t times with the capital X to the square. Okay, very simple. Okay, now we found that the velocity of the system is equal to alpha e. Let me look right here. Okay, this is the velocity here. So we found that it is equal to this is velocity. This is velocity here, which is alpha e power of alpha t times x to alpha e power of alpha t times with the x here. Okay, and then plus with the exponential power of alpha t times x single. So plus with the exponential power of alpha t times x single. Okay, here. Now another equation, which is the displacement, which is equal to here alpha square and so on. Okay, so alpha square exponential power of alpha t times with the x plus 2 alpha e power of alpha t, and then times with the x single dot plus with the exponential power of alpha t times with the x double dot. Okay. Now from here, we can do some substitution inside this equation. Okay, here is the longest part lah. Okay. Don't worry, okay, I'll do it slowly, don't worry about it. Now let's write back x double dot plus gamma over m, x single dot plus omega naught squared x is equal to 0. Sorry. Okay, let's do some substitution. So alpha square, x double dot is equal to alpha square, right? So alpha square exponential power of alpha t times with the x, okay, plus with the 2 alpha exponential power of alpha t times with the x dot plus with the exponential power of alpha t times with the x double dot. Okay. So this is x double dot. Okay. Now plus with the gamma over m, and then times with the times with the alpha e exponential power of alpha t times with the capital X, okay, plus with the exponential power of alpha t times with the x single dot. Okay, close bracket here. And finally, it is equal to plus omega naught square x equal to 0. Very simple. Okay, now I want to do what is called as the factorization. So we have the exponential power alpha t, exponential power of alpha t, exponential power alpha t from here, right? So let's put out here. Let's put aside here. So we get that it is equal to exponential power alpha t, open bracket, alpha squared times x single dot, x capital X only, okay, and then plus with 2 alpha times with the x single dot, and then plus with the x double dot, right? Principle. Okay. Now plus, let's copy back. You only get gamma over m times with the. Okay. I need to chill out first. Plus with the alpha e power of alpha t times x plus exponential power of alpha t times x single dot. Okay, let's copy back. And plus with the omega naught square x equal to 0. This is capital X, okay? Capital X. Okay. Now, let's look here. Okay, now I want to do some of the same as the previous one, which is factorization. Okay. Now we found that this one is equal to exponential power of alpha t alpha square times x plus 2 alpha times x single dot times x double dot here. Principle, right? This principle. Okay. And then plus with the exponential power of alpha t. Okay, don't worry about this. Okay. Exponential power of t, and then I'll open up the bracket here, which is equal to y over m, right? Because y over m times with the alpha, right? This is equal to y, gamma over m, and then times with the alpha times with the x single dot, right? Here is just like this, okay? Y over m times with the alpha times with the exponential power of alpha t, and then times with the x. Okay, this is what it is. Okay. Okay, now plus with the x single dot. Sorry, y omega over gamma over n. Okay, times with the x single dot. Okay. Is it really like that single dot here? Wait, let me see. That single dot here. Yeah, it is. Okay. X single dot here. Okay, and then yeah, it is. Sorry. Okay, and then cross bracket here, and then plus with the omega naught square x equal to 0. Now, here we want to do some what we call as addition, okay, penambahan. So we have here, this is like a quadratic, okay. Let's say that this is in the group A. Okay, let's say that x is equal to A in the group A. Okay, group. This is group, and x single dot is the group B, and x double dot is the group C. Okay, now this is right now here is the group A, here is the group B, and here is the group C, right? And here we have the group B, here is the group, this is group C, this is group B, sorry about that, and here we have the group C, sorry, group C. Sorry, this is A. This is A. Sorry. A here. This is A here. Sorry. Okay, it was correct. Okay, sorry. I was confused just a bit. Okay, let's look at here. Okay, now let's find here. Exponential power of alpha t. Okay, times with the. Okay, here like I said, I want to do addition. Okay, so that means A plus with the A plus with the A. So what we got is here is A squared plus gamma over m times with the alpha times with the omega naught square, and here all of these are multiplied with s. Right? Here times with the s, here times with the s, here times with the s. Okay? Very simple. Okay. Now, okay, let's plus again, and then open bracket. Now I want to play with the group. Wait, I want to do some addition in the group B. Okay. So this is group A. Now this is group B. Here is the 2 alpha plus gamma over m, and then times with the x single dot. X single dot here. Okay. Present. Now plus again. Open bracket. Bracket C, which is the only alone here. So it is 1, and then times with the x double dot. Okay. Now I want to show you what is in the lecture note. This right here. Okay, this is C, group C, right? This right here will put on the first. What is that called? What is that called in English? I don't know what is it. Okay, this one we put first, and then it follows by this one, and at the end is here. So we finally get that. I want to do some what we call is the ascending order. It starts from the biggest how many what they call the biggest x. Okay, the biggest x double dot. The biggest is x double dot. So this is in the first row. This is in the second, and this is the last one. Okay, so how do you get that is equal to 0? So exponential power of alpha t multiply with x double dot plus with the 2 alpha times gamma over m times with the x single dot plus with the alpha square plus gamma over m times with the alpha times with the omega naught square x single dot. This is equal to 0. So notice that this is actually a solution for the exponential power of alpha t here times with the x t. This is equation for the displacement, right? Right here. So when we do some comparison here, this is the same as this one, and xt is equal to clear all this equation. So finally we find that x t capital T is equal to x double dot plus with the 2 alpha times plus gamma over m x double dot plus with the alpha square plus gamma over m times with the alpha plus omega naught square. This is so this is what we call this is what we call as the displacement. How do I say this? It's like a new form. Okay, a new form. Let's just say this is a new form. A new form of formula. Okay, this is it. Okay. Now let's move on to okay. Okay. Now they want to do from here. As you can see, this is like a quadratic. Okay, this is like a quadratic equation, which is x square plus ax square plus bx plus c, right, is equal to 0, right? This is like the what we call it as the quadratic form. Okay, this is like a quadratic form, quadratic equation. So we want to make a resemble into this. Okay, into this. So then make it that ax square is equal to alpha square plus with the bx as the gamma over m x, and then plus with the omega naught square equal to 0. Okay, this is like from here. this is this one. Okay, this one resemble to alpha square. Sorry. This is resemble to x square, x double dot. Sorry, plus with omega gamma over m x single dot plus omega naught square x. Okay, this is resemble to this one. Now then transfer it as a quadratic equation. This is one right here. Okay, now here is where I want to do some of the substitution. So this should be is alpha. It's like x squared plus bx plus c. Okay, that is okay. Now I want to do some of the what's that called as the substitution. Okay. So what happens here is that alpha squared is equal to x double dot, and then plus with the 2 alpha plus gamma over m x single dot plus with the alpha square plus gamma over m times with the alpha plus omega naught square, which is x equal to 0. Okay, this is like this up here. Now when we move this one to the right side, we want this one to the right side, this is equal to 0, right? So finally we get that it is x double dot plus 2 alpha plus gamma over m and with the x single dot equal to 0. Reciprocal. Now here is where you want to do from here, okay, from here we want to find out what is the value for this one. What is the value for this one? So here we want to find the solution for this one. 2 alpha plus gamma over m. We want to find it from here. And from here, we want to do some of the quadratic solution, which is, if you remember correctly from the secondary school, which is x equal to negative b plus minus square of b square minus 4ac over 2a. So I want to do some let x as the alpha. So a is equal to 1, okay, and b is equal to gamma over m, it's simple, and then c is equal to omega square. Okay. Please bear in mind here. Now here I'll do something. Okay. I'll write back. Okay. So alpha square plus gamma over m alpha plus omega naught square. Okay. So here is the A, here is the B, here is the C. So I want to find alpha. It's like a quadratic. Okay, it's like a quadratic equation. So alpha is equal to negative b. Okay, I'll write back here. So s equal to negative b plus minus square of b square minus 4ac over 2a. So negative b is actually negative gamma over m. Okay, and then plus minus with the square of b square, which is gamma over m square minus with 4a, which is 1. This is 1. Okay, times with the c, which is omega square, omega naught square, and then over with the 2a, which is 2 times 1. Now alpha is equal to negative gamma over m plus minus our square of 1 gamma square over m square. Okay, we multiply each other, then we get this one, and then minus with the 4 omega naught square over 2. Okay, this. So far so good, I think so. Yeah. Okay, now we do some of the easier form, which is 1 over 2, right? 1 over 2 times with the negative gamma over m plus minus square root of b square, sorry, not b square, gamma square over m square minus with 4 omega naught square. Okay, this one. Okay, now we want to do some of the what we call it as the dividing. Okay, dividing. So when we do some dividing, what happens here? We get that. Okay, we get that. This one. 1 alpha is equal to 1 over 2 times with the negative y over m, right? Okay, and then plus with the 1 over 2 plus minus with the gamma square over m square plus with the 4 omega naught square. Okay, basically. Okay. Now I want to do some much more easier. This is the toughest part. This is the toughest part to explain. Okay, let's go. Alpha is equal to negative y of gamma over 2m and then plus with the square root of gamma square over m square plus 4 omega naught square over 2. Okay, when we want to do some of the dividing in the square root, this right here has to change as the square root form. It's like we are doing right now. Alpha is equal to negative gamma over 2m plus minus square root of gamma square over m square plus 4 omega naught square over square root 2. Okay, so far so good. Now, square root 4. Square root 4. Okay. When we do some square root 4, in this here, when we do some dividing, this right here will become this right here will become 4, right? It's like we do like this: square root of omega gamma square over m square divided by square root of 4, right? Which is equal to square root of gamma square over m square times with the 1 over square root of 4. So finally we get that it is equal to gamma square. So the square root of gamma square over 4m square. Okay. Here. Now let's look on another side, which is square root of 4 omega naught square divided by square root 4, right? So square root 4 omega naught square is equal, multiply with 1 over square root 4. And finally we can cut off this down. So we get that it is equal to square root of omega naught square. Yeah. Okay, now let's do some of the the substitution side here. So alpha is equal to negative gamma over 2m, right? Plus minus square root of here gamma square over 4m square. Okay, and then minus with the omega naught square. Okay, now let's put here on the right side. So alpha plus gamma over 2m, which is equal to plus minus square root of gamma square over 4m square minus with the omega naught square. Okay, now we want to remove 2, so that means 2 will go here, we go here. We'll multiply the left and the right side. So finally we get that 2 alpha plus gamma over m equal to 2 plus minus 2 times with the gamma square over m square minus omega naught square. So here is the form of 2 alpha plus y over m. From here we can do some substitution. Let's go back here. So here is where we can do some substitution inside this equation. So x double dot plus 2 alpha plus gamma over n, and here x single dot is equal to 0, right? Now substitute here. So x double dot plus with the 2 plus minus 2 times with the gamma square over m square minus omega naught square equal to 0. Alright, basically. Okay, let's see what's next. Okay, so you know that 2 alpha plus gamma over m is equal to plus minus 2 square of gamma square over m square minus omega naught square. Okay, so as you can see, when we put this one to the right side, we found that acceleration is equal to 0. This is the most important news. This one right here can be used in our three case. Later we will explain, which is the case 1, case 2, and the case 3. And each of these case, has their own displacement equation. This one also has their own displacement equation. This one also has their displacement equation for the damp oscillation. Each of the cases has their own equation for displacement for the damp oscillation. Okay, now let's move on to the types of cases. Look at the key cases here. Key cases, which is we have, this is the case, we have the case 1, and we have the case 2, and we have the case 3. So both of these have their own properties. Okay, so case 1, it is say that, square root of b square minus 4ac. If you remember this right here component, okay, this right here is square root of b square minus 4ac. We have learned about 3 of them, which is either equal to 0 or less than 0 or more than 0, right? So b square minus 4ac is actually from here. This is b square minus 4ac. Okay? So it is said that the first case is equal to 0. So that means square root of gamma square over m square. Sorry, 4m square. Okay, and then minus with omega naught square is equal to 0. Now I'll skip this part because it is such useless notes. Okay, then I'll just go straight to the point. Okay, so case 1, actually gamma is equal to 2m omega naught. When this properties is the same, okay, when the damping constant is the same as this one, we call it as critically damped. Okay, stop for a second. Okay, now we can find a solution. Okay, to form the displacement of the depth oscillation on this case critically. Okay, so let's go back. Okay, we know that x is equal to negative b plus minus square root of b square minus 4ac over 2a, right? Okay, let's go back. Okay, we know that alpha is equal to negative gamma over m plus minus with the gamma square over 4m square minus omega naught square over, sorry, it has not be over 2a because this is already very high. Okay, that's because we already divided by 2. Okay, so that's why I just read earlier. Okay, from here, this is 2m. Okay, let's look back here. Okay, which one? This one. This is equal to negative b plus minus square root of b square over b square minus 4ac over 2a. This is already divided by 2. Okay, so this is why I get this form right here. Okay, now we know that in this case, gamma square over 4m square minus omega naught square, okay, is equal to 0. So when it comes to 0, we found that alpha is equal to negative gamma over 2m. Okay, and then we found that gamma is equal to negative 2 alpha m. Now we want to do what is alpha? Okay, we want to find what is alpha. Okay, so we want to do some of the equalization between both of these. Okay, so we know that gamma is equal to 2m omega naught. So here we find that 2 alpha m equal to 2m omega naught. So here we can cancel out this one, and 2 and divide it by 2, and finally we get that negative alpha is equal to omega naught. So alpha is equal to negative omega naught. Okay, this is what alpha is. Okay. Okay, what next? Okay, now before we want to form a displacement equation, okay, displacement equation, we want to relate to these two components, which is velocity and displacement, velocity and acceleration. So we know that acceleration, as I mentioned before, is always equal to 0. From this case right here, okay, so from this case right here, we transfer this to the right side, and we found that x double dot is equal to 0. This is what it means. So when is x equal to 0, we want to find, okay, what we want to find, what is the velocity. What is the velocity of the system when the acceleration is equal to 0? Okay, now let's go back. Here's the okay. So x single dot. Okay, we know that x single dot, x double dot is the rate of change of velocity, right? It is dx single dot over dt. Okay, now we want to find x single dot, which is x double dot det is equal to dx single dot, right? So from here, if we want to find x single dot, we have to do some integration. So when we do some integration, this can be removed, okay, and we do some integration. That means to find x single dot, we have to integrate acceleration with the respect of time. Okay. Now we know that x double dot is equal to 0. So x single dot is equal to square root of 0 dt. So when we integrate a constant, when we integrate a number or a constant here, okay, we finally get that x single dot is equal to C1 So how come did I get C1? Okay, I'll show the integration. So we know the rule of the integration. Let's say that dy over dx equal to t. Okay, t. Okay, now I want to differentiate. I want to find what is y. Okay, to find y, we have to integrate t with the respect of dx, with the respect of x. Okay, it's like how we do some of the turnaround here. So let's say we have y, and then if we want to find dy over dx, okay, we have to differentiate. Now, if you want to find the original form, you have to do some integration. Now, I want to do some compare. Okay, let's get into physics. Okay, let's say that I have displacement which is x. Okay, now if I want to find velocity, which is rate of change of displacement, I have to do differentiation. Now, if I want to find displacement when I have velocity, I have to do integration. Same as this one. If I want to find velocity, if I want to find acceleration, which is rate of change of velocity, I have to do differentiation, same as this one. Now, what if I want to find this velocity, which is rate of change of displacement? I have to do integration from the equation of acceleration. Okay, that's pretty simple. So here, when I integrate here is equal to t power of 1, okay, plus 1 right here, okay, we have to plus 1 here, okay, and then over with 2, okay, why 2? Because 1 over 1 plus 1 equal to 2, and 2 will becomes as our denominator, and then finally we plus c here, so y is equal to t square over 2 plus c. Okay, what if we want to integrate a constant? Okay, say that y is equal to, let's say it is equal to 3. Okay, 3. Now, so dy over dx equal to 3. Now we want to find the original form. So y is equal to integral of 3 dx, right? That means I have to integrate 3 with respect of x. Right now, this is a constant. Okay, this is a constant. So what happens here is that y is equal to 3 power of x equal to 0, right? Because 3 times x power of 0 is equal to 3. Okay, now plus 1 equal to 1. So plus c. So y is equal to 3 x plus c. Pretty simple. So when it comes to 0, y equal to square. Let's say that dy over dx equal to 0, right? So y is equal to 0 dx. So y equal to 0 power of x power of 0 plus 1. Okay, and then plus with c. So we get that y equal to 0 times x. Okay, 0 times x is equal to 0, and then plus c. Same as this case as this one. Do you see that? Okay, same as the case as this one. Here, this case is just the same as this one. That's why we get x single dot equal to c1. Okay, now let's look on what is the displacement for this system. Okay. So what we want to find from the here. Now we have here. Okay, this is velocity. Okay, velocity, which is x single dot, and here is x double dot. Okay, now we want to find what is the displacement. So we have to do integration. So we have to integrate with respect of time. Okay. So here x double dot. Okay. is equal to dx single dot over dt. Now we want to find x. Sorry. I messed up. Okay. X equal to x single dot is equal to rate of change of velocity. Okay, and then we want to find displacement. So x single dot dt is equal to dx, and then we want to do some integration here. Okay, it should be enough here. Okay, so remove. So we find that x equal to integration of x single dot at the time with respect of time. Okay, what is x single dot? It is c1. Yeah, so it is x equal to integration c1 dt. Okay, so let's integrate it. So we get that x equal to c1 power of t equal to 0. Okay, and then plus with the 1 over 1 plus with the new constant. So we get that x equal to c1t plus c2. Like that. Okay, perfect. Okay. Now let's look on back to the first equation. I'll do some reminding here. So xt, okay, equal to exponential power of alpha t plus, sorry, not plus, it's equal to x capital S times with the x capital T. Okay, very simple. Now alpha, okay, when we talk about the alpha, okay, we know that alpha, okay, alpha is equal to negative omega naught, right? So substitution, x t is equal to exponential power of negative omega naught t times with the x t, which is here, okay, times with the c1t plus c2. So this is how we calculate the displacement of the system when it oscillates critically down. This is important. Okay, this displacement. Now, when it comes to the velocity, I don't think you will ask the velocity because it does in the lecture note, it doesn't even explain it. Okay, so let's just ignore it. Okay, now let's move on to the case 2. How long did I record it? It's been like 45 minutes. Okay, I will continue in the next part.